In this video, let's just quickly go through the app architecture and view model. Okay, so what is an app architecture? Well, architecture provides guidelines to help you allocate the app responsibilities between the classes. A well-designed app architecture helps you scale your app and extend it with additional features. Architecture can also simplify team collaboration. So the most common architectural principles are separations of concern and driving UI from a model. So we're not going to look at that, but the recommended app architectures that follow those guidelines are these. We follow those guidelines by creating this UI layer and data layer. Okay, let's also read them. Separation. What does separations of concern mean? The separation of concerns design principles state that the app is divided into classes of functions, each with separate responsibilities. This is vague as hell. We're gonna look at it when we start building some big, complex applications. Drive a UI from a model. The drive UI from a model principle states that you should drive your UI from a model, preferably a persistent model. Models are components responsible for handling the data for an app. They're independent from the UI elements and app components in your app, so they're unexpected by the app's lifecycle and associated concerns. Okay, so first let's in this video we're gonna implement the separations of concerns guidelines. We do that by creating UI layer and a data layer. So essentially they are like folders. So let's look at the UI layer. The role of the UI layer, our presentational layer, is to display the application data on the screen. Whenever the data changes due to any user interaction, such as pressing a button, the UI should update to reflect the changes. The UI layer has these two components, UI elements and state holders. UI elements are basically Jetpack Compose elements, and state holder, which is a view model. What's the purpose of the view model? Well, it holds data and it exposes it to the UI and handles some app logic. We're gonna look at what it does. Okay, the view model component holds and exposes the state the UI consumes. What do we mean by that? So far we created a state variable inside of our composable, but from now on we're gonna move that state to a separate file. The UI state is application data transformed by ViewModel. ViewModel lets your app follow the architectural principle of driving the UI from the model. Damn, they're going on a rant here. Essentially, guys, the reason we're building the we're implementing the view model is because we want to keep all the state variables somewhere separately. We want to keep all the states separately, and view model also as an additional benefit, it survives the configuration changes. So the last time, for example, in order to make our composable or variables retain its value across configuration changes, we use remember savable. But if we use the view model, view model automatically takes care of storing your variables, objects, whatnot from changing from the configuration changes. Okay, in this video I'm gonna show you how to quickly implement ViewModel using simple apps. we're not going to use the app um, provided in the documentation. Instead, I'm going to build a simple um, counter app. This counter app gonna have a state. So instead of using mutable state, I'm gonna use the view model to store that state, and we're gonna somehow make the view model communicate with the UI layer, which is our composable. Both view model and UI layer, which is our Jetpack composite elements, are on the same layer. There's also a data layer, whatever, but so the goal is to create a view model, and then we expose the state inside of the view model to the Jetpack compose elements. Okay, like I said previously, in order to create UI and data layers, we just need to create two folders, one for the data and one for the UI. In the UI folder, we're gonna keep the view model and any UI components we need. And in the data folder, we're gonna keep the UI state and data source files. So I have already created them. So you need to create the data and UI folder inside the view your app name, inside your app or whatever your app name is. So they are both inside the ViewModel test app. So data and UI. Inside of the UI, I have created counter view model and then counter screen, and then inside of the data I am created this counter UI state class, and then data source I have nothing inside of it. In the main activity, I am importing the counter screen. This counter screen well, this is a simple screen that displays like this. In this app, I'm gonna keep the view model simple, all the so we can understand view model lot easier. I have a column. Inside of this column, I have icon button and a card. Inside of the card, I have a text, and then two spacer elements, two spacer composables, and a button. So this gap is because of the spacer elements, and this is a button, and this is a I'm using an image for the icon. Okay, that's pretty much it. You can, from what you already know, you could probably create this on your own. So I'm not gonna go over how we created this. It's already simplified. Okay, so the first we need to go to the view model. It's in the UI. So okay, how do we make this class UI model? I mean view model. First, you extend your class from view model. Okay, that's the step one. I have steps for this. Let's go. Tell the compiler that we are gonna need the view model. Okay, I skipped that one. Well, in order to tell the compiler that we're gonna use a view model, we need to go to the let's go to Android tab, example. Where is it? We need to find the Gradle file. Okay, so it's probably here, I believe. Okay, it's in here. If you go to the Android tab and go to the module app Gradle file, we get the dependencies. Inside the dependencies, we need to add this implementation something. Even though I did not add this, it probably asks that, I guess. I think we have a lifecycle runtime. I don't know how that's possible. Okay, so when you add a dependency to the dependencies block, you're gonna get a pop-up saying to sync now. So you're gonna press that sync now button. It will start syncing. Wait for it to get synced. Meanwhile, let's check why. How is that even possible? Android lifecycle. So we need to get the view model from the Android x.lifecycle.viewModel. That's the step 1. What's the next step? Okay, the next step is setting up a view model. Okay, in order to set up our view model, we just extend our class from the view model, which we already did. Now set up state. There are two ways you can set up state. One, we already know, we can use the state to set up. Another way is flow. To really understand flow, we need to know Kotlin's coroutines. At this point, we really don't know, so I'm gonna like tell you what it actually does instead of going through the implementation detail. Even if we did understand the coroutines, the implementation is really hard to understand. And then get data. In this app, we're not gonna get data, and I'm gonna add simple app logic. Okay, so let's go to our data. I'm gonna make this data class, and here I'm gonna import that, and I'm gonna pass that to the flow class I told you earlier. There are two flows. One is a normal flow, and then there is a mutable flow. The object we pass to the mutable flow can be edited or written. Okay, so I'm gonna use the mutable flow for now, and pass. Okay, that's not it. Mutable flow off, I believe, and we need to use the counter UI state. Well, after you create the mutable state flow, we're gonna expose the UI state as just state flow. It's not gonna be mutable. So to do that, we're gonna use what the documentation calls backing property. Okay, so let's do that. So this is just state flow. It's not a mutable state flow. So if you wanted to, you could also give this the same thing, counter UI state, and okay, now that we made the UI state just the readable data type or something, now we need to expose this UI state to the composables. I have one in which is inside this counter screen. I'm gonna go to the parameters. Inside of the parameters, I'm gonna call the counter ViewModel, and then we're gonna use the ViewModel. Where's the ViewModel? Okay. Notice that this ViewModel is different. Android X lifecycle ViewModel compose ViewModel. This is from compose, and if you go to this is a lifecycle ViewModel. These two ViewModels are different. If we pass it like that, the compiler or whatever automatically knows that we want a counter ViewModel, because that's the data type we're telling this counter ViewModel is gonna be using. This ViewModel is gonna automatically find the this ViewModel and instantiate for us. Okay, so the UI state is in the flow, state flow. However, we for composables we just need states. We're only interested in states. States are what allows the composable to recompose to it's the only thing that triggers the recompositions. Well, there's a way to make the state flow state UI state as collect as state. That's pretty much it. We're gonna say the counter UI state or something. If we go at the go to the counter UI state, there's only one thing, value, and that's the default value is 0. Let's go to the counter screen, and in the text we're gonna use the value. Since that state, whenever the value changes, this text component's gonna update. Well, let's use the $sign and counter UI state dot value, and let's run it. Then what happened? Counter UI state value. I'll be back. Okay, so in order to get the value from the state, we need to use the value. So now we get the actual object, and then inside of the object we're going to access value. That's kind of confusing because I used value for uh, the state. Anyway, now we created the view model and we somehow transformed the state flow to state. Now we have a state, and if the state changes, our app's gonna should trigger recomposition. Okay, so let's try to update the state. How are we gonna update it? Well, I have something. Where is it? Okay, so this, we need to understand this diagram. The view model provides the UI composables state, and the UI elements such as buttons and text fields, they trigger events such as on-click events and on change value events and things. These events we could handle them. These are the only events that communicate with the we somehow need to make these events communicate with ViewModel and update the ViewModel. So the state from ViewModel we get the states, from the UI events kind of travel to the ViewModel. So this is, in the documentation they refer as unidirectional data flow, which is weird, I think. In this video we're probably like calling out concepts we are blindly using. So probably we've been doing this, I think. So now, where is it? The button has an on-click event. How we somehow need to using this, we somehow need to contact the view model. How are we gonna do that? Let's go to the view model and let's create a function that handles that on-click. I'm gonna just call it increment. And this, well, how do we increment mutable state flow? Well, if we access the we can get the value if we call the value on the object. Now we can change the value. First let's get the value. I'm gonna assign the value to some variable, current value. We can access the UI state only inside of the this class because it's private. We made the UI state we exposed outside of this file is just a read-only variable. So now we have a current value, and we assign the current value plus 1 to the UI state. Why are we getting this? None of the following is because of the receiver type mismatch. Okay, I'll be back. Okay, so I keep forgetting the UI state. The value returns an object. So that's what happened here. That returned an object, and we call the value on that object. So let's call the object if we are working with the object, right, we can use the copy. Inside of that, we're gonna pass in value, current value, god damn it, +1. Okay, previously I just used like this, right? It doesn't work. Why doesn't it work? Well, we, for the UI state value, we're passing an object, which is what is it, counter UI state object. This just returns an integer, probably, right? It probably returns an integer, so we can't assign that. But if we copy the object and replace the value with this one, we get the object and we would have changed the value. So now we have a function that increments the value. So we somehow need to call this function when we press the button. We have the ViewModel, which is, where is it? Counter ViewModel. And we're gonna call the increment. Let's see what happens. Okay, now we are able to increment it. I also have this button. Let's try resetting it. Let's go to the view model again, and here let's create a reset function, and here this just resets the UI state. Again, we're gonna copy the current, what if we just copy the view value and pass in value dot copy. For the value, we're gonna pass a 0. I feel like this is a wrong way of doing the thing, but it could work. I'll be back. Anyway, since this works, I'm gonna leave it like that. So now we gotta go to the this button, where's start. Here it is, and we're gonna call the reset counter ViewModel and reset. Let's try incrementing and then press the reset button. So these two buttons work. We somehow managed to add the state to the UI layer, and then we added some logic inside the view model, and we let the UI layer communicate with the view model and change the state. So the thing with the view model is, if you wanted to use the state in any of the component, all you need to do is just use the view model. The state, if you create this app with the state object, state object and the composable will be coupled together. So if you wanted to use the state, you would probably need to voice that variable up somewhere so that both the composable can use the variable. But with this, you don't really need to do that. All you gotta do is just use the view model, and all the instance of the view model is gonna have the same state. Also, they're not mentioning it here, but using the with the view model, the states, right, they're always like changing. But let's say you have a state that keeps updating somehow, but if we like exit out of the app, the state stops updating, because it's a feature of this mutable StateFlow object. I think it's not possible with the plain compose StateFlow. Also notice that this is a feature of the coroutines, and if state is just, I think it's a compose thingy, I think. Anyway, that's pretty much it. So we somehow told the compiler that we're going to use the view model by going to the app Gradle file and pasting in the implementation dependency, and then we set up the view model by extending our class from the view model class, and then we set up flow. We can also set up the state, mutable state, but I did not show that here. And we didn't get the data, but I showed you how we can add some app logic and how we can make the UI communicate with the view model, and view model communicate with the UI model. And that's pretty much it for this video. Let's look at what a StateFlow is. So StateFlow is some sort of like a function or something. So when you pass a object to the mutable StateFlow, the object becomes this, a mutable StateFlow. So in the video, I passed the UI state object. I passed the UI state object. So what does it mean if object becomes a mutable StateFlow? Well, when an object becomes a mutable StateFlow, we can observe the changes that happens to that object. For example, we can get the value of the mutable flow object by calling the value method. Let's say I have assigned the mutable StateFlow to the UI state variable. I can just call the state I can just call the value method. This will give us the current value. So whenever the object changes, we always get the new value. Like this, we can access the new value, and wherever we use the this variable, like let's say I have assigned the current value to a current value variable, and wherever I use this variable, I always get the current value. But normally we don't usually use the current value like this. We make the value state, so that whenever the value changes, we also want a recomposition in order to make this value, which is, what is this? In order to make mutable state flow state, we just use collect as state. So far we've been using the mutable state of. We can probably pass in like a string. We can probably also pass in object as well. This mutable state of belongs to compose, I believe, but flows belongs to Kotlin coroutines, which we aren't familiar as of right now. But one huge advantage with flows is that the values like I said, it keeps updating, but when we exit the app, the value stops getting updated. So it saves some system resources if you use the flow. I believe there are more advantages for using if you use the StateFlow. Maybe look into why we would use a StateFlow versus just mutable state. That's pretty much it. There are two types of flow. One is just plain flow object, and another one is mutable state flow. Here you can see the difference between flow and mutable state flow or state flow. At this point, we really don't know about Kotlin coroutines and flows in general, so I don't expect you to understand what this means. Let's quickly look at how we would implement flow and mutable state flow. First, let's define this function, number flow. This function just returns a flow object. We can use the emit to return the values. This is a this function is we're not creating this function from scratch. Instead, we are using the Kotlin coroutines flow function. So inside of that flow function, we can emit values using emit, and then we can call collect to collect the value emitted value. So the values you're gonna probably get is like 1 to 5. So every value is gonna be like 1, 2, 3, 4, 5, something like that. So whenever you like collect the flow, it's gonna run this code again. What about mutable state flow? Okay, like in the previous sections, we're gonna initialize the mutable state flow, and then we're gonna assign it to StateFlow variable, and we have a state updating function. We're gonna use the value on the mutable state flow. So we get the current value. We can now just go to the our custom composable. Here I'm assuming this composable is somewhere else in our um, project. So we have a track StateFlow composable. This accepts view model. We know how to hand out view model, and then we're gonna collect the state like this. App ViewModel StateFlow collects as state. StateFlow is just the mutable state StateFlow, and we're gonna consume the StateFlow object. And somewhere else in our code we're gonna update. So what happens when you update the values? So whenever you use the collector state, the values the state, you're gonna actually get the latest values from the mutable state flow. So you won't get the first initialized value. So it checks the last update and gives you to the variables or wherever the state flow is used to collect it. That's pretty much it.